Mhm. Yeah. So this one is a separation of this. Okay, if once there is a clear distinction of the data points, then we can come up with this one, a line which separates it out. That's what we have discussed with kind of like a line equation, which is above and below. We are looking for it so that one side it is a positive and other side is a negative, and down the line it is zero. So we are looking for an equation where a single neuron is sufficient to separate it out the class points where it's separated by a line especially. So one single neuron can sufficient to develop such thing. Yeah, that is sufficient. Now we have seen AND gate, OR gate, and XOR gate. That's I ask you for exercise. I hope you have working on them. Then yeah, I give some kind of exercise. This one now. This is quite different. You can't separate straight blatant line equation like this. No line equation exactly separates it out. Whatever you try best fit. So it definitely um, putting some of the points in other side. So now um, how do you do this one? What's happening? Like, how do we classify these kind of points when there is no clear line which separates it out? So, at least, now my question is, how many lines are required to do this one, or how many neurons? That's the question. The least number of neurons, such that without any activation function, of course, we're not doing any activations here. There's a clear separation, either two classes, either positive or negative. So, so tell me from your side, like how can we do that? Like I given enough time for you to work it out. Have anybody come up with um, idea right now? Even I need a neural network which separates these 2 points. Solution. Like what comes to in your mind when you see this problem first? What are the thoughts? they need not be the correct ones at least.
Sir, here in one hidden layer, we can use multiple neurons based
Yeah.
on that,
Mm.
and some output bias. We can separate these things, sir. Like
Okay.
we have only two input
Yeah, two
and
inputs, like two inputs, that is the coordinate x1 and y1, only
yes, sir.
the points. Okay, I will keep it as x and y, that's in general variables. Instead of x1 and y1, xy. Now, if they are line, the one neuron is sufficient. Suppose if it is uh, only, then this is sufficient actually. This is w1, w2, let's say it is a b1 or b simply, don't have any. Then you will be having an equation here, a kind of uh, the w1x plus w2y, uh, w1x plus w2y, mm, plus b. So you can keep up a kind of, you keep up some kind of you can say like w1x plus w2y plus b, you can say is a greater than 0. Then you can bring it one output. If it is false, if it is true, you can say it is. If it is false, you can say it is 0. That means you are taking the sides of it. Like if you have a line equation, this line equation is a w1x plus w2y plus b. On the line it is 0. It's one side if it is a positive, and other side it is a negative. Yeah, I'm not checking which side is positive or negative, but in general, one side is positive, one side is a negative. So if it is a positive, then you can blatantly say this one, the point is belongs to this positive side, otherwise point is belongs to negative side. That is how you can say it. So this is a simple single neuron, it separates it out. If the data is simple, now the data is not this way. Now the data is not a line. It is no more, it is clearly separates it out. So what do you do? Like, you just need to extend this one. How do you extend? That is my point of question. So what it is doing, the same thing you should think of in perspective of this one. If there are no these points, or you can say clearly, you can write up a line equation like this, and this is a positive side, it's a negative side. But there is something which you cannot do that. So what you can see, you can think of how many lines you can draw within this so that they can separate it out. Like you see, I am drawing a line. This is a one line which is a kind of like separation for one region. Okay, so I will extend this line to. Okay, there is a line equation. Line means it is not a line segment; it is a line. You can say like you then you can think of like drawing a solid line itself. It doesn't matter actually. Uh, a solid line, we'll think of it later. How to deal with is a line which is separating it out, a red completely, but there are green points in other side. Now what I do, I will take up another line which doing something like
Yes, sir,
which
then it will.
yeah. Okay.
We can
This
use only two lines, sir. Yes, sir.
yeah. Now you can think of doing this one. Now there are two lines. Now you think of it like you bring up a kind of a system where, so now think of it like these two are exactly separating it out. Now you can, this one is positive, this one is negative complete, but now there are multiple regions, not just the single region. If you extend this one to uh, if let me expand, if I extend this one like this, because of lines can be extended, these are the line equations we are looking for it. So now there are four regions, this one, this one, this one, this one. There are four regions and three regions of one category. Let's say this is one, and the other region is zero category. Or otherwise, you can say this is one, these three are some other category. Okay. Now, now the question is, how do we get this? How do we get this these two line representations, which exactly gives four regions, and we can separate it out whatever comes in this region, this region, this region, and this region. Okay. Now you have, let's say you have two expressions for these equations. Let's say this one is w1x. Let me write up in the same color. This is a w1x plus w2y plus b1. Right. Now this line equation would be, now these are the two different weights, w3x plus w4y plus b2. Now if you have two such expressions, okay, now if you have two line equations which are intersecting, then how do you express inequation? These are the just I've written them as a line equations. They are equal to zero. I'm not mentioning them, but on the line they are satisfying the line equation. So the points on those lines are equal to zeros. On the points, one side it is positive, one side is negative. That means like one. Let's say if you take this blue point and I, what do you say? This may be, um, which one is a positive? This, I think this is a negative. Am I correct with respect to the lines they are representing the coordinate axis? In this one for the blue, this is a negative, and this is below it is positive. Am I correct? Verify once with respect to this coordinate system.
Yes, sir.
Are they true? Verify. I just random. I'm not verifying. I'm just collecting and writing from my memory. So that's why I'm just asking subject to verification. How do you verify?
Yes, because x is given x by x, and then if you x equal to zero, then our option will
I
need
I,
to be
I think
yes. That's why
your voice is breaking. Am I audible clearly for you, all of you guys? Like, because I could not hear you properly.
you are audible. Am I audible? Hello.
I
Hello.
can't hear you. I can hear you with the broken.
The network. Am I audible? Excuse me.
I could hear you pieces. Can anyone answer me? Like in this one, are these correct? The negative and the positive sides of this line?
Yes, yes, sir.
Yeah, fine. Okay. For this above line, the W1x plus W2y plus B1, which one is positive and which one is negative?
Below side is positive, upper side is negative, sir.
Below side is positive and upper side is negative. Okay. Now you will be having four combinations for every region. If you take this green region, this pink region, this one, what line equation should get it? The the blue line equation should get negative, and the yellow line equation should get negative. And this one, blue line should be negative, and yellow line should be positive below. And this region, the third one, both must be positive. And this one, last region, the blue is what? Blue is positive, and other one is negative. So if these things like negative positive, positive negative, positive positive, then we can say that accordingly, like these are all comes under one category, this comes under one category. Similarly, we have seen something, we have earlier, we have done something under class or whatever. Yeah, this one, right? So here we have only two sides. If comes this side, we say that like it is a positive or this is a negative, or we can say accordingly one and zero, because we have true, false, these kind of things, like true, false, true, true, false, true, false, false. Only four scenarios are here. Now here it is a different thing. We have many now. So now if we express this one into the truth table, how do we express? To give a point, given a point, to make them sure that they are belongs to one region, either green or pink. How do we express? Which gate it can say, it can do it? Can you see the gate? Negative negative. It's a false false. True false. True true. This is true false. We can clearly think of like one gate is satisfying for this one.
Uh, or gate what? Or gate?
Yeah, you can say OR gate. So OR gate is doing this task. So how do we implement that one here? Now, how do we, now question is about OR gate is fine, but how do we come up with the two equations with OR combination? We need a OR gate. OR gate between what? OR gate between, not between two lines. OR gate between these two combinations, these two lines. How do we impose those two lines as two OR gates? That's what my question. Like, how do we get up with the architecture of neural network now? You have X, you have Y. These are the only thing inputs you have. Now you have one line equation, that is W1x plus W2y plus B1. This is a W1. This is W2, and this is, let me keep it like this. This is a B1. Now we have another one for another line representation, that is W3x One is a W4, this one is B2. Now we have two lines equations, and we have, of course, there is greater than 0, you can say, that is a positive, um, greater than 0 and greater than 0. If both are greater than 0, they comes up with something. Okay, so now you apply OR gate here. You apply OR gate here between these two. So then you will be having final answer. Okay, so then this would be either true or false. So now what you have to keep it here, you keep it here either 1 1, so that if both are true, then if you apply, okay, now gates can be shifted accordingly, because and or quite like same thing, only not will be replaced by that. Like one is a true, false, false, false. Other one would be false, true. Sorry, and this one would be if both are true, then true, then all false. That is for and. If both are false, then false, and the rest all the things are true for the OR gate. Only the thing is a kind of like mm, a kind of like true, 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 and false, false is false. In between, if one of the thing is false, all the false and all the things. So you can use it, because our nature of problem is three comes in one side and one is a different side. That is also satisfied by this gate as well as this gate. So you can use either of the thing. Our target is to separate it out. Whether you use all the three things are false with true, or all the three things with true with one false. So that's up to you, what you will be using. So now you can think of here, if both the things uh, accordingly you have to adjust accordingly how you name the things, like which one is negative, negative, which one is positive. If you think of this one is the numbers as positive, this one negative, and this one is a positive. For this problem, this would be negative and this would be negative. So this would be false and false region. This would be false and false region. So that you how do you adjust this one, false and false region, to get a uh, to get a separation it out with single negative, negative, false. So if you supply a pink point, it should come as a false. How do you come up? How a pink point is supplied here? Let's assume that a pink point is given as an input, and now we are expecting both are negative, as then it should be false. So that means a false means I am expecting a 0. How the outcome could be 0? What should be done here? And if it is blue point has three regions, and not blue, green point. Green point has three regions. One is positive, one is a negative, negative, positive, positive, positive. I am talking about these positive negatives comes out of these things. That is the key. And pink point is just simply a negative negative combination. How do you separate it out? This almost answer is in front of you. You are not cracking it out. How the pink point can become as a negative, and let's assume that these pink points gives the 0, and this will be 1 1 1. The green points exhibit proofs. So negative, negative, that is a false, should be 0, false, 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 true, false, true, 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 false, true. So or get. So how do we come up here? What do you do? Can I separate it out or not, first of all? Is it possible?
As y will be greater than 0. Using that, sir, one can separate, sir. It is possible greater than 0 will pass 1 or else will pass 0, sir.
Okay, so you are applying a not gate at the end. Or you can do, there are two ways, like you can keep it as less than 0. That's what you are saying. It is both are less than 0, then they comes as a 0 0. Okay, so if it is a true, if it is a true, if it is uh, also true, that means both are negative, then pink exhibits. And now if it is true, if it is false, that means true false means if it is less than 0, less than 0, that means a negative. If it is true means, and this one is false, that means it is positive, but it is less than 0, then true false. But here we are having OR gate. True false will give the true answer. So all the green points comes as a trues, and the pink points comes as a false. Simple. Either 0 or 1 comes with this one. Okay. So now uh, both 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 the green and pink points are separated out with the two line equations. Okay. Now just for the sake, now I think it's better I ask you to do this in the program. Take some kind of manually choose points in the xy coordinates like this way, and you can't separate it out with a single line equation, that is assured, but it should not be more than two lines. Make it sure that it can be only possible with the two lines can separate it out. So if you do that, and now aim is to find out who is this W1, W2, W3, W4, B1, B2. These things need to be figure it out properly such that the regions are established. How that is could be happen? That could be happen with only the training procedure. That's what I could say. Like you have to the answers for the green regions, and the pink regions, pink points already. You are naming them as these are all one category, these three are other categories. Automatically once you pass them each point with their labels, so the w1, w3, w4, b1, b2s are set out with a proper numbers, and they will be these regions, these boundaries, the decision boundaries could be established from the data. Now the theoretical point of view, like my question is about now if you have something like this, I will give some more complex thing. Okay, not very much complex. let's say if we have another pink points, let's say no, not like this. Let's say this is a pink point, and you have green points. Green points are like this. So let me draw some more so that they are enclosing. Let's say like this. Now tell me. Now my question is about how many neurons are required. How are you making a decision line boundary? Now you can you think of like can able to do a line predictions like multiple lines like this can separate it out this situation? If it is not, then how do we proceed? I need a neural network without any activation function. Make sure that we have not at all used any activation function. We are just using the powerful concept of less than or greater than, positive or negative, beside a line equation. This is the affine function, of course. Affine functions, we are using it, affine functions with inequations. So affine inequations, can you apply affine inequations here? The same like earlier, so that these 2 points classes can be separated out.
So instead of using linear equation, if we use equation for circles, sir, uh, degree 2, sir, then we can separate, sir.
No, we like I understand. Like we don't have such a network. We so far like neural networks are completely restricted with affine functions, where we apply W transpose X plus B. On top of it, there is a F. This F is a kind of like the activation function. We use it. So now your question is about like instead of this line, take the circle equation, and how do we like you are transporting the entire coordinate system into other one. The coordinate system is basically Cartesian to now taken Cartesian systems are kind of like horizontal grids like this, and now polars are the circles. This is a different coordination system, but our neural networks are built on the coordinates. That is why we write R into RM all the time, the transformation. And the definition what we do here, that is R into RM with affine functions only. So the affine functions are the lines are separating, not the rings are separating. Okay, so these are all like different neural network systems. If you build a different neural architecture, and assuming that that neural architecture is a dense class should be, as like we have proved, shown that. So that is a different thing. Using affine classes, the lines. Oh, you mentioned like here we have to use activation function. Can't we do without activation function? Why can't we do like if I try this one, like let me draw something. A line equation is like this. 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 Let's assume. Okay. Now I have multiple several regions, not like just like 4 earlier. We have four line equation so that you can think of how many regions it could maximum possible. So now tell me, if I can able to draw like this, how many neurons I required to draw these four lines so that they are separating it out. So now I can say that the region bounded by all these four lines, that is this one, I can say one class, and the region outside of this, then any region, no matter all other things, I can call it as other class. So I need another two more lines, four equations, so that they represent this one. Four line equation. Of course, it is a crude approximation. We cannot bring a kind of like circle. We cannot get a circle with the four lines. So, so what is the neuron now? My fundamental question is about is how many minimum neurons are required to develop this. I'm not
Four
asking
minimum,
about
sir.
how many.
Four, sir, minimum.
Minimum four neurons because of four lines.
Yes, sir, because if we divide a region into positive and negative, each
Yeah.
neuron will be separating it out, sir. Positive side and the negative side.
Mhm. So four neurons could separate this one. Like now, okay, my strong feeling, my strong suggestion for all of you, those who are wanted to know eagerly what's happening actually. Now, I would just wanted to uh, uh, discuss with you something like how these weights B W1, W2, B1, W3, W4, B2 are being decided such that they are forming the regions that you should feel it. That is I want like that would be possible only once you take couple of sample examples like this one earlier, this one, and you manually tweak out those variables and these weights and biases such that how these lines are moving one side with other, such that the data points are the key. They are trying to come up with some kind of converging point where they exhibit the distinctive boundary layers such that they separates them out. So here the main things are the main separation things are these weights. So you should feel them. These separations are well established from the data. If you take very few amounts of data, you cannot guarantee it. That is why you have to take large quantities of data so that the weights could be much clearly they can separate it out. So even I wrote here large number of points, at least 100 you can think of. uh, then out of 100 you can say around 30%, 30 to 40% one category, other is other category, then you draw them out. So this uh, I implement with our Python or something, so that you could able to come up with the four neurons with what combination, how do you apply and how do you come up with such that they will separate it out. Okay. This is all about the classification of the things. So like if I go something like much, I could say much harder or much complex. Let's say my takeaway is something like the some spirals. I will keep it up. Like there is a pink. Let's say let me draw it. Like these are all dots. Your data is like this. Your data. x1, these are all points. Don't think of as a dashes. These are all like x comma y points on the coordinate system. I'm not drawing coordinate system here. Okay, these are all pink. Let me take another one. Which color I'm using? Green color. Yeah. So there is uh, another spiral which is exactly comes like this. These are all again dots, points. Your x comma y points. The pink ones are one color, and the greens are another color. Now, what is this decision line, the which separates it out? What neural network structure will separates this actually? This is the uh, complexity of the problem of earlier versions. Now I just added the AB complexity. How do you think of this one? The pinks are other one class and greens are other class. Is there a neural network can separate this one? First of all, is it possible? What is the difference between earlier kind of problems and this one?
Sir,
What?
there are
So
multiple
earlier,
layers. Uh,
Oh, okay.
That's why, sir.
More come some more answers. What is the decision line here? The decision making, can you separate them out? If I wanted to draw a decision line, how to draw?
Sir, can we use here activation function? Yeah, without activation function.
Okay, we'll come to that. Now the question is about what activation functions are doing. That's what I wanted to make you understand clearly before that. Like why activation functions? Why activation function does the job of something else? Without activation functions, you have discussed already beginning. Without activation functions, it is a linear combination of linear equations, again a linear equation. So
Yes, sir.
finally you will end up with again a line equation, but you don't get any non-linearity. So here activation functions can be used, of course. Now the decision layer, if decision boundary layer, like not layer, boundary line or boundary curve, like you can think of like this one, which is separating it of both pink points,
Yes, sir.
right? This one. Oh, sorry, like this. Is it clearly separating it out? How many layer, how many things will require? There should be
I guess two things, sir. Two layers.
two spirals
Yes, sir.
should come out so that the region of band, they are defining a band so that they don't so now you can say clearly that the things between these two will green, the things below this one is the pink. So this one is the green region. You can shaded them out. This one is the pink region. So everything is separated out now. Okay, so this complexity of problems can we will discuss like what actually neural network is doing inside in this classification. Now I just simple examples. You try it out with the Python and get them the line equations properly. You draw them, picture them, and plot them in the using matplotlib, such that you could able to see those line equations uh, with the data on top of it, so that you can think of like, and see, first you can start with other examples like different examples you take up, like uh, let's say a sine equation, sine curve. Take some any function, and above sine, below sine there is one region, you think of it is a pink region, below region, and above you take it as a green region. And now think of it like, how do you get this curve? You don't know curve initially, but your data is the key. Like, take the samples from the green, take the samples from the sample points from this green region, so take the some sample points from this pink region, uh, collectively, let's say 200 points below and 200 points above, and now our target is to find out a curve is separating both the things. You are not telling the computer to sin x, but you are using sin x to generate the data points, and you are using neural networks to mimic the neural function works as a sine curve. So literally, you are approximating sin x with the neural network. Okay, so these are all experiments. You should have to do it. All these things by taking the conceptual ideas and take your own functions and do it, and experiment with the different neural networks. And yeah, so now that's all about like how do we separate it out, and how do we approximate the functions using the classes sin x, using the classification of data points. Okay, I'm moving further. These are all kind of like using uh, here I have just asked you to without using any activation function, so that lines are coming it up. Now here you can't do them without activation function because of it's a non-linearity sitting here. Even if you try to use the, of course you can get it, but you will always come up with like kind of like a line segments like this. You don't exactly get a curves. You will get only a piecewise line equations. We'll separate them out. You don't find the curves in it. So now
Yes, sir. In this case, sir, our complexity also increase, sir. Like if
yeah.
we take only line segment.
Yeah. So a lot of line segments will come up. Then a lot of regions you need to work it out. How do we keep the points in one side and other side? So activation functions. Okay, before touching that,
Sir,
yeah,
I have one doubt, sir. But in
yeah.
real life, sir, we don't know ki how our data points, sir. Then, like if we have data, then how we can approach? Like just it satisfy only simple neural network, yeah, we had multiple hidden layer, yeah, which activation function works. There are lots of possibility.
Oh yeah,
Then
yeah.
how we
That yeah, that is depend. Like I'm not talking about the variations in the network architecture. Network architecture is a kind of a big variable box. So the number of neurons, the number of the layers, or which activation function, and even further while tuning, how much the steps and the step length you have to take up, all those things are the hyperparameters. Those are all like subject of the problem description. The no one doesn't know in general answers for these things. It is all problem specific, and the problem need to be the problem solver who is setting it up the neural network. he will know the much better than anything. Like the region of the domain knowledge is a core thing to decide those parameters. And of course, assuming that there is maybe in our artificial intelligence course or some other course, if you are taking the advanced, no, I don't think it comes under neural network, maybe artificial intelligence, or maybe advanced machine learning, I can say. There is theorem called no free lunch theorem. Did I told you about this one?
I guess no, sir.
Okay. There is theorem called
I'm not
no.
sure, sir. Maybe I forget that. But
Okay. And there is some theorem called no free lunch theorem. I'm not describing this, what is this theorem and all, say statement and all. Like this theorem statement is quite mathematical and statistical workout. It requires a lot of prerequisite to understand, make you understand. I'm not touching that, but I can explain in a very layman term without any mathematics. Kind of like uh, the essence of this theorem is. Uh, there is no perfect model in the world. There is no perfect model in the world, but some models. Okay, I think there is something called, I can explain much better way. I If I take the essence of this one, um, yeah, there is a no uh, there is a no oh no, I don't call it as there is no also. It's because it is contradicting effect. I can say something like all models are bad, but some of them are good. Some of them are not good, some of them are useful, I could say. All models in the world are bad, but some of them are useful. So that is what this theorem says. So machine learning, artificial intelligence, whatever you name it. So we theory is so sophisticated and we can do anything, but model construction is very difficult. That is why we are almost reaching a point of stage. The mod to develop new models is very difficult now. So, in the scientific computing or in any further advancement, always look for some mathematical breakthroughs or a new technologies, maybe theoretically mm, or computationally, we need to evolve in a next level so that we can think of further point. So don't assume that whatever we are discussing feels like works everywhere. It is not true. You will offend if you really rely on mathematics and if you really rely on theory, especially theory hurts you a lot when you are dealing with practice. Okay, these are all kind of like once you know advanced courses like artificial intelligence and machine learning, advanced machine learning with statistics, there you will understand the difficulties of these things. I hope you are doing some courses on these advanced things. I guess you maybe next semester or this semester. I'm not sure. You will get to know all them.
yes, sir.
Yeah. So, but I will put you in a one direction. I could say like my fundamental things are like give enough information or enough details, logical breaks, so that these things, whenever you read any advanced courses or those things, you will be very comfortable with the subject whatever you go in future, like machine learning area, especially. That's why I'm putting these in front of you, breaking down the uh, internal components of neural networks. Okay, let's see. Let me put up something Mm, like I could say, yeah. So let me go back to your engineering question, was it M1 or M2 course, I'm not sure. Suppose if you have a curve, if you have a curve, let me take a curve like this. I'm just taking not this. Okay. Suppose this one, this one is the end points of this curve in between A and B. Now, if I wanted to find approximate this curve, how do you approximate with the lines? Then, if I draw some kind of partitioning A and B, you know this much better from the Riemann integration. Then, if you know these points and the functional values of this one, the dots, what I am keeping, then what do? You line segment them up, line segments. Then almost it is approximating. It is a piecewise approximation to that curve f, whatever you say, the function f of x. Now, if I don't have that one, that those functional values and all, now let me take up this one, the same uh, copy. Now, let me take up kind of this. Okay. Now, if I draw a rectangle for everywhere, draw a rectangle. Some of the rectangles may be side by side rectangles, of course. So what they are defining actually, if I know these rectangles, if I know these rectangles, I can say something about my function. Like they are actually telling me how my function is looks like. So if I make this if I make these rectangles much smaller, I can get the f of x. Are you agree?
Yes, sir.
So these rectangles are actually building my function f of x. Now my fundamental thing is I am coming back to the same neural network again. How I can construct this this rectangle in a neural network. A piece. Before going to the multiple rectangles, how can I construct a piece of rectangle so that I can insert multiple of them by varying width and height. So there are two parameters for every rectangle you choose. I can vary width, I can vary height. If I can able to develop a neural network which produces rectangles with multiple widths and multiple heights, and if I could able to combine all those rectangles, as many as rectangles, suppose let's say 100 rectangles or 1000 rectangles, I could able to fit up those rectangles within this region and with certain width and certain height for every rectangle according to my target. So then those rectangles actually representing my function f of x. Now how can I develop um, a rectangle, a single rectangle with with and given width and a given height, not given width and a particular width and a particular height, using this same uh, simple concept. This one, yeah, you can think of this one. Now think of it how that is possible. Developing a rectangle. First of all, how many neurons are required? I don't want any, again, furthermore, I'm saying I don't want any activation function. I'm not using any activation function as of now till. I will come to that activation function a little later. Think for some time. Don't think of function approximation through the rectangles. I'm just looking for, I want to mimic a particular rectangle, a single rectangle, such that I can develop further if I want it more.
Sir, for creating a rectangle, we need four lines, sir.
Actually, I don't need of lines actually, rectangle. Okay, I will define what a rectangle means here. Here, my meaning of rectangle is not actually computing this rectangle, because we are approximating, our target is to looking for the function approximation, but through rectangles. That is our final goal, through rectangles. Now, who is I don't care of it, these lines and these lines and this line. I need only this one, because I know where it is, the width of this one, the height of this one, right? This is the only thing I required. This segment,
Okay, sir.
this line
Okay.
segment piece, and how much width it is, how much away height it is from it. I don't need to construct these lines. These lines doesn't have any meaning to f of x. Only this piece is having enough information, how much width is required, how much height is from this bottom. That is what. Now, so you now understand. I just wanted to construct these pieces. For time being, construct a single piece, so that I should have a control of that single piece, how much width should be it is, how much height should be it is from the axis. So this width and height should be my tuning things, so that I can generate different widths and different heighted rectangles.
So I guess here only one input required,
Yeah, one input,
like
of course. Yeah,
one
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 input.
input,
One input
one
X.
bias, one
Yeah,
input, one bias,
yeah,
and
one
y
input, one bias.
one.
Yeah.
Yes. And then we can in one hidden neuron we can like x equal to something.
Yeah. Now, yeah, right. You are coming on the line, but now think
Yes.
of it: one input X and one
One in,
B. This is a W one, you can say. Now, how many neurons are required? That is the question now comes up.
I guess sir only one neuron x equal to one
Yeah,
because
think
it's
of it.
horizontally. Okay, sir.
I need both the weight and height should be in the control of it. How do you control the weight, width, and height of the that lines piece?
Sir, in one hidden neuron, if we put W1 X1 equal to B1,
Mm.
It will work, sir.
No, no, don't try randomly. Now, let's
Because
think of it. One hidden neuron, if you think of W1x plus B, what it is doing, it is what it is establishing. It is establishing simply, uh, think of it, what it is doing actually. It is a line equation with slope W1 and B.
I am saying W1 x equal to B,
W1,
x equal to B. If
no,
this
no,
condition,
that equal to B here, this one is a computational unit. We don't equate anything. We make it either conditional here actually.
okay.
It should be a conditional, whether it is a greater than 0, less than 0, or a number. Based on that, we will take the decision what would be outside. It should output something.
Sir, I guess two hidden neuron and two outputs, sir. One hidden neuron also comes and one output gives the width and another output give the height.
Okay, like do you use? We need that the segment which essentially doing the job of the up and down thing. Suppose let's say let's focus on simply like what I'm asking. The question is a simple way of saying something. Develop a neural network. Let me give some kind of like ping points here. Let's say ping points. Okay, two ping points, not three. Uh, Develop a neural network which produces which produces uh, this uh, which produces this red line. No, not this. This one, right? Single rectangle. Given two dots, it should pass through that. So now my question is, how do we get this single uh, step function with a neural network? It is easy. As you mentioned here, let's take another neural network as this one is B1. This is B1. This one would be W2x plus B2. Now this one, let me give some other color. This one is for W2. This is for B2. Now it outcome should produce this graph. Output should be this function. So whatever it is printing, that's it. This graph. That means x is this one, the input, the x-axis, the input you are supplying. The output should give a signal, one signal. So now how do you think of it? Like what controls the things?
We add some output bias also, beta 1, beta 2.
Yeah,
So
that is
this one will
B1, B1, B2 are there. If you just simply pass W1x plus B1, W2, B2, and here you have something here, and again it's a linear combination, again a line will come up, but you don't never get this signal. I want that signal. So to achieve that signal, what modifications do we do in this activation? I mean, not activation function. These are neurons.
So here we use step function.
Yeah, yeah. Step function. How do you use the step function?
Like in region, sir, we can say like from starting to
Mm,
some region, our y value,
mm,
output value will be 0. After that, our output value will be some bias value b1. Then
mm,
again, that will be 0. In
mm.
that kind of, we divide in split of regions, sir. Like for
Yeah.
creating one rectangle, we need to create 3 regions, sir.
Okay. Right. Like yeah, the your comes close to it, but I will give the step function details as you said. Like suppose you forget about the for 5 minutes, next 5 minutes about the problem. I will give you know the step function. the step function is a kind of like x less than 0 0 and x greater than 1 1. This is the step function, you know it, right? This is the usual
Yes,
step
sir.
function. This is the step function. Now if I shift this step function little bit away, then that means like it comes a kind of like this one, this one, right? If I push the step function to some point here to this point instead of 0. So original step function, let's say f of x step function definition is 0 if x less than 0, 1 if x greater than or equal to 0. Now what is this one? This one is
F of F
uh,
of x minus something.
f of x minus the
Minus
point wherever you are, let's say
yes, sir.
the point is b, x minus
B.
b
Yes,
equal
sir.
to uh, 0
If
if
x less
one
than
is
b.
x less than b or 1 if x greater than b. That is shifted.
Yes, sir.
That is, you
Yes,
know
sir.
it very well. Now if you have two such step functions, let's say let me draw another one more step function on the same graph. I don't take another graph. Let me take another step function of this kind, this one, on top of it this one. That is, let me take that one as this one as f1, uh, f1, and let me take that one as f2. F2 of x equal to like, let me take this one as a b1, so that I change this b1 b1 b1. Let me take this one as a b2, the point, there's a different thing now. This one would be f2 of x minus b2. So now 0 if x less than b2, 1 if x greater than or equal to b2. That is sure. Now you think of it, something I can do f1 and f2 such that I can get this region. What I can do with f1 and f2 so that only I will get this one. And that so what should I have to do? That means like these two functions, this is red is f1 and green is f2, and what combination I should do f1 and f2 such that my resultant would be this pink one. So it comes as b1 as this one. At the b1 it should be this one, and at b2 sorry, it should represent this one. So tell me what f1 and
F,
f2 I have to do such that it will
eh,
hinge up at b1 and hinge down at b2.
the F1 plus F2 in B1 into B2. Interval is the B1 from B2, and our function is we can do F1 plus F2
No,
here.
I have to do it on the entire line.
On entire line.
Entire line. This is the f1, f2. Our x we are defining on the real line. I'm not talking about neural networks. On the real line, we have a function f1, f2. There are two step functions. One is stepped up at b1, one is stepped up at b2. Now, what f1 and f2 I should manipulate? What operations I should do with f1 and f2 such that I should get this pink curve? Yeah. Now this is. Tell me, apply. Simple.
If x less than B1, then F1 plus F2 value, and if x between B1 to B2, then also F1 plus F2 value, and after that B2 if x greater than B2.
Why are you thinking too much on this? Like, what happening? See, think of it very carefully. Below B1, both the curves are coincide. After B2, both the curves are coincide, right?
Yes, sir.
You take the advantage of it.
Then we can, like, below B1 we can say F1 and F2, and after B2 we can say.
No, you don't need to then. Like this one is same, this one is same. If you subtract it out, this will become this minus this is 0. This will subtract f1 minus f2. This will become 0. Both are same, right? So that
Yes,
is
sir.
what we want, right? This one
Yes,
is
sir.
f2. This one is f1. F2 is below. F1 is, that is simply f2 minus f1, or f1 minus f2. I could say f1 minus f2. See, it's simply f1 minus f2.
Yes, sir. Yes, sir.
Yeah.
Yes,
If
sir.
you
Yes,
subtract f2 from the f1, you are getting that. You don't need to do anything.
yes, sir.
Yeah. Now apply this concept here above. How do you get this signal? So you are getting a rectangle. Now think of it.
Sir, again I am doubts I have. Like
Yeah.
here we need W and W2, directly we can say, like, if X less than B1, then that will be 0, and if other part is not true, then that will be 1, and if X less than B2, then that will be 0. If X
Now you
greater
can
than.
think of like instead of that one, you can think of applying. Uh, I can say something like here. If you think of clearly, this one. This is a line equation, right? This is a x minus b is a line equation. X
Yes, sir.
minus b2 is a line equation. Uh,
Yes,
so
sir.
so you can think of this w1 would be 1. Okay, w1 would be 1, so x plus b1. W2 is also 1.
Yes, sir.
So now you think of x plus b1 and x plus b2, same like this one, right? We are
Yes, sir.
constructing. Now
Yes,
you are applying a step function on top of this one. So you are
yes, sir.
applying, let's say, let me write up a step function on top of this one.
Yes, sir.
Now you are getting a step function, but now the question is about uh, now the variables, the height and this one, who is deciding? That is what my question about. Like, who is this? Who are these? The width is deciding. Who are the things which are deciding this height? That is my fundamental beginning of the question. Now think this one. This is a very important. Who is deciding this width and who is deciding the height, so that my neural network need to be tuned such a way that I have a full control over this signal, this rectangular signal.
So difference of biasness
Yeah,
decided the width,
yeah.
and difference of functional value of that step function decided the height, sir.
But the functional values we can't say because functional value, suppose, yeah. Now let's suppose in this signal as well. Let me consider. Uh, I want a kind of like this one. This one is a kind of like um, here at 50. I want a signal with height 50. Okay, well, forget about neural network for some time. Now, what would be my, step function is this one only. The step function definition is this one only. And this is a B1 point and this is a B2 point. I'm not talking about the bits right up now. I am focusing on the height. I want this one. What should be my F1 and F2 such that it will come?
here some extra biasness, मतलब extra parameter also we have to multiply, sir.
Yeah,
Like
what you write? Like tell me exactly like 50 I want it. So tell me the here F1 F2 is giving just simply it is again it is at 1 only. It is not giving the 50 height.
we can then we can say 50 into F1 minus F2.
50
Mm,
uh 50 times
F1 minus F2.
F1 minus F2. Yeah, right.
Yes, sir.
So is it giving 50 minus F1 F2? Is it 50 F1? If 50 F1 is taking this one to 50 height, and if this is a 50 height, so that 50 F1 minus F2, yeah, it is giving. So now what you doing? There are weights. Those who is defining those 50 or 100, those weights are sitting here, right? So this one is what W1 times. This is what you have done. W1 times. This is F1. This is F2. W1 times F1 plus W2 times F2,
Yes, sir. Yes, sir.
right?
Yes, sir. Yes, sir.
So that is those W1 and W2 are actually giving the how much height it should be. It should maintain. And who is giving
Yes,
this
sir.
width? The width is given by B2 and B1.
Yes, sir.
How far the B1 and B2 are separated? How height W1 and W2 are there? Now we are getting a rectangle.
Yes, sir. Then, sir, in
Yeah.
output, for like output, sir, how we can calculate the difference in this diagram, B1 minus B2, sir? Like,
Oh,
I am
uh,
asking, sir, you can separate like W1 F1 plus W2 F2. That will
uh.
give the one output. That will be the height. How we can draw the diagram for
Yeah,
width
diagram is just
from
simply
this?
it is a function. Let me talk about this. Let me for time being, I'm not keeping this as a plus. I'm keeping it as a minus for not to confuse with other step function. Let's say this one is x minus b1, x minus b1. This is x minus b2. It is just a simply step function. You know the step function, that is you defined here step function. That step function actually hinges out b1 at the b1, and this step function hinges out at b2, and this is just simply a function only. Now what is the outcome? Like if you write up like my outcome is capital F of x, or simply f of x. How do I writing this one? This one is step of x minus b1 w1 plus step function of x minus b2 w2. Okay, now you give me whatever signal I can produce, b w1 and w2, b1 b2, such that I have a rectangle now. So now supply over the real line. If you apply this function, now I will get the signal, single signal. This one is coming, right? If you put some b1 b2 w1 w2, and you will get a signal, this one. Let's substitute. Let's if you take up something like in that function, if you choose b1 equal to 5 and b2 equal to 10 and w1 equal to, let's say, 5, w2 equal to, let's say, uh, okay, w1 equal to, let's say, 3, w2 equal to, let's say, 6. Now what is coming there? What is your f of x?
So
Your f of x is
3 into
3 times
x
step
minus 5
step
step
function
of
of x minus 5
5
plus 6
plus,
times step function of x minus, what is that, 10.
yes, sir.
Now what is this? If you draw this one, what you will get? What you will
The
get?
height will be
So suppose
mm,
let draw the first one. If you draw the first one, the if you draw the first one, hinge at 5, height is 3. So this would be a kind of a blue line comes here and touching at 3, and this one, and um, this is this one, right? This is the
Yes,
first
sir.
piece. This is the
Yes,
first
sir.
piece. And if you draw the second piece, let me take the green, and which is hinge at 10. Let's say this is the 10, and this one is height is what? Height is 6. Somewhere it is going up. This one. Now tell me what is happening here. You will see different than that, but you will get a quite odd signal. Yeah. So now these two are not coincide here. Now you will get 0, but these two things are not coincide, so that they don't come up, because there is a difference here. So we will always maintain the same weight for W2 as well, so that we will maintain the other way. So that, like, always put in -1 rather than this one, so that we are adding it up all the time, the plus, so that this one would be -3. This is our target, right? So now what is happening? What is the signal here? That this is again, this is a 3. So the opposite signal, this is 3. Now what you are getting here? You are getting a kind of a signal with this one, with the height 3. Understand?
Yes, sir.
Yeah. So this minus is not the part of the signal. This minus we are separate for the subtraction. Okay, that is
Yes,
how
sir.
it is separating it out. Otherwise, you will be amplified with, if you take up 3. That is what, because we are using here the plus in the original equation, linear combination. So this W2 is minus is sitting comes here, so that these two the upper signals gets cancelled out. So here you can say simply this, instead of W2, you just simply a single variable, that is minus W1, so that you would be having a kind of like minus W1. So it produces a clear signal of rectangle, right? Now you know the controls. What to control? There are only 3 parameters, that is W1, B1, B2. That's it. So B1, B2 are the things which are width controls, and this single W1 is the height control. Now where we started, now we are here. Now let me focus on, let suppose you take some sin x curve, or some whatever curve you choose, function, some function you choose. Let me choose some kind of hat. Let me choose this parabola, inverse parabola. Now I need to approximate this one with 4 rectangles. If I ask you 4 rectangles, that means, like, choose this one as one rectangle, choose this one as another one more rectangle, take this one as one more rectangle, and this one as another one more rectangle. Okay. Four rectangles are kind of comes like this, which are slightly uh, get this one. Now if I, how to produce these 4 rectangles to produce this one, to approximate that curve with the same approach, I need 4 such. You have now the controls for one rectangle. You have controls for W1 and B1, B2. Now I need 4 such rectangles such that they fit here. How do you do that? let's forget about 4. Now you have 1, and how do you bring two rectangles side by side? How many neurons are required? For the another to put another one more rectangle, let's say this one, let's say like this one, uh, how many extra neurons are required for that?
I think for this one, sir, only no other neuron required, sir, for two. Because if we take another output, so I think required, sir.
So
Extra
how do
neuron
you,
also.
now I need a function like signal. Earlier you have only one signal. Now I want something like to fit two rectangles. I need a kind of like coming with nothing, and I have a little bump here and little down here, and uh, again at the same point I have again further bump. I could not say this one, this one should go up and go there and comes down. This is what, right? Representing two rectangles. Now I need this signal.
Then,
Yeah.
sir,
Now
for
develop a
width,
neural network such that which gives this signal. Yeah, do it. I given enough details to construct a single one. Now you need to update to produce multiple uh, combinations. Think of like how many neurons you are expecting to build that to come up with another edge, another rectangle
we,
side by side to it.
one more neuron, sir, one more.
Simple one more
Zero.
neuron.
Yes, sir. Like for like calculating width, sir. Like for like there is the width. Then in this case, B1 minus B2. If we create another rectangle, then we need some other value.
Hmm.
Uh, B1 minus B3 or B2 minus B3, something like that, sir.
But here and this signal, if you think of it, I did not say that. And this one may be another width. This one may be another width.
Yes, sir. For
This
this, we
may be
need three.
different height. This is different height.
Yes, sir.
Yeah.
We need three biasness and but two outputs, sir, two height. So
Two
then we
output.
add.
No, we are not outputting anything. We are not outputting is real to real only. Our function is real to real always. Function is real to real. This we are mapping. This is this function, right? F of x. F of x is a function from R to R, but it has jumps at certain points. These are the jumps because we are using step function. Okay, you try them out. Exercise. If for two construct it, I strongly suggest you guys do programming and just go with the theory. You visualize the stuff, whatever I am doing it. So then further exercises like you take a simple curve y equal to x square, y equal to x cube, whatever simple thing which you can able to manage. Um, then try to fill it up as many as rectangles in a curve, so that that is representing the curve, the function. So approximating means we are putting several hundreds of rectangles uh, inside a particular curve like this or like this, so that our function, our neural network, whatever neural network we are taking, that behaving as a function, as an approximator of rectangles, right? So you just imagine, this is this, if you keep all the rectangles, if you know how to construct all these rectangles, and now I have kept around, let's say, 1000 rectangles, let's say, within this short region, with small width and the height which are matching with this one, then definitely the my neural network is mimicking my function f of x in terms of rectangles. You agree?
Yes.
My neural network is no more a signal, no more a single piece of signal, as I'm keeping stacking all the rectangles under a particular function, and by choosing, holding height and width properly, so that this itself now giving my function. Now question is, how many neurons I should build down the line, for each rectangle, to, let's say, to 1000 rectangles, how many neurons are required, and
Yes, sir.
this given, yeah,
I think, sir, like if we want to create n rectangle, then n plus one neuron required.
yeah,
Then
that is you explore it. I am not sure of it, like, for your answer, I don't think that is n plus 1 is not an answer. You can, again, you do it by pen and paper and use Desmos, maybe is the best place to draw them. You know Desmos, right?
yes, sir. Yes, sir.
Yeah,
Yes, sir.
you draw the simple, this one first, then in the Desmos, and then add one more rectangle to it, and look at it how many neurons it is. Then later you convert that into the program, into the Python, to approximate a function. That's the best. Okay, so I don't think that n plus 1 is not an answer. Yeah, you work it out all this, and we will, um, I will come up maybe in the next class with, we will discuss something, maybe extensions of this one. I You tell me.
On Sunday, sir. Saturday,
Sunday.
because there will, yes, sir, tomorrow there will be many club sessions, sir. So till 4, 5, many
Okay.
of us not free. After that you can take, otherwise Sunday, sir.
Okay. Okay. Then in such case, I will inform tomorrow. Okay, on Sunday time.
Okay,
Okay.
okay, okay, okay,
Okay.
sir.
Right. Thank you. Bye.
Thank you so much, sir. Bye, sir.